So, hello everyone. In the series of revision classes, we have discussed function in our last class. So, firstly, what is a function? Function is a special type of relation from A to B, and in which element of A is known as the input, and the element of set B is known as the output. And function is defined as from A to B, means from input to output. Okay. This is the pictorial representation of a function that is known as mapping. And next we have discussed the how function can be defined. So there are two conditions for a function to be defined. First is all element of input to be mapped, and second one is all element of input have a unique image. Now we have seen in the various example like that. So in the first one element is left in the input, so this is not a function. In the second one element has two images. Okay, an element has two pre-images, but an element has not more than one image. Okay, you have seen that one image is alpha and one image is beta, so it is not a function. But it can be happen that one image is alpha, two images alpha, three images alpha, means one image is unique as alpha, two images is unique as alpha, three images unique as alpha. So this is known as your function. But there if one have two images alpha and beta, so it will not be a function. Next we have discussed the type of function. Sorry, firstly we have discussed the images and pre-images of a function. So images of a function can be defined as the set of all the elements which are to be mapped from set A to set B. So the images are the element which we have found by mapping, and pre-images are the element which are the images of the element. Pre-image is image of the image of element. Okay, so all the element which from where the mapping is started is known as the pre-image, or you can say simply as the all the elements of the input is known as the pre-image. This is also known as domain of a function. Domain is a set of pre-images, or you can say that the set of input images is known as the domain. And the range of the function is defined as the set of the images. Okay. And codomain is all the values of input is known as codomain. Now, next we have discussed about the independent variable and dependent variable. X is known as the independent variable because the value of x can we can put any value of the x, and y is dependent variable because y is depend on the x. Now we have discussed various type of function x square under root x, and next we have discussed the exponential function, the domain and range of the exponential function, the domain and range of logarithmic function. Now in today class, sorry, one more is left, that was greatest integer function or stepwise function. Okay, now in today class we will discuss another type of function. Then we discuss about one on to many one, and one and many one function. Now the first uh, type of function for today is modulus function. Modulus function. So what is modulus function? A function in which we can put any value inside the mod, so we get a positive value from it. So generally the input and output. So the input of modulus function is from minus infinity to infinity, or we can say a real number, and the output is from 0 to infinity. 0 is also included. And the graph of the modulus function is like that. That was your modulus function. Okay. Now next is signum function. So what is a signum function? Signum function is denoted by sin x, SIGN-X. Okay, it gives only three value. If we put any positive number, so it will get, you will get 1. If you put any high positive number, so you will get 1 only answer. If you put any negative number, so you will get -1 as an answer. If you put 0, so you will get 0 as an answer. Okay, so what is the domain? What is the input, or you can say the domain of signum function? We can put any real number inside x. So it is from 0 minus infinity to infinity, or you can say the r. And the range of a function is -1, 0, 1. For any negative number, you will get value only -1, and for any positive number, you will get value 0, sorry, 1, and for 0, you will get 0 as a value. Okay, so the graph of that function is like that. 0, 1, 0, 0, 0, -1. Now next is identity function. Identity function means you will put any value, so you will get same value. Suppose the function is fx is equal to x. That means its domain is from -infinity to infinity, and its range from infinity to infinity. Okay, you will put 1, so you will get 1. You will put 3, so you will get 3. If you will put -1, so you will get -1. And the graph of that function is like that. That is known as your identity function. Next is constant function. Constant function. Constant function means a function has fixed value. Suppose fx is equal to k. Now, if you put any number inside f, inside k, inside x, so you will get only one value, that was k. So f1 is also k, f minus 1 is also k, f100 is also k. Okay, so the domain is from -infinity to infinity, and range is any number, let it be k, and the graph of that function is like that. That is known as your constant function. Now next is your even function and odd function. Next is even function and odd function. What are the even function? What are the odd function? First is your even function. If f of minus x is equal to fx for all x belongs to the domain of f, is known as the even function. Its example are x square. Fx is equal to x square. Now, if you put f minus 2, so you will get -2 whole square as 4. And if you put f2, so you will get the value 2 square as 4. So a function which have different output and we get this, which have different input and we get the same output, is known as even function. the value of f2 and f minus 2 is equal. So that value is known as the even function. And next is odd function. What are the odd function? That if f minus x is equal to minus of fx, for all x belongs to domain of f. Example, fx is equal to x cube. Now if you put 2 as an input, so you will get 8 as answer. If you put minus 2, so you will get minus 8 as answer. So f minus 2 is minus of f2. So that was your odd function. Now come to the main part, the type of the function as injective, bijective, onto, into, surjective, all type of function we are discussing now. Now the first is one function. Now the first topic is your one function. One function. What are the one function? A function f a to b is said to be one or injective. The another name of one function is injective function. One function or injective mapping. One function or injective mapping if different element of f, if different element of a have different f images in b. F images means functions images in b. F images in b. We can write this function as injective function. So what is this function? If fx1 is equal to fx2, then x1 equal to x2 for all x1 x2 belongs to a, or you can say that fx1 is does not equal to fx2, so x1 does not equal to x2 for all x1 x2 belongs to a. So that was your one function. One function means a function which have only single mapping. Okay, unique map. So unique image is known as the one function. Unique image or unique pre-image. Now suppose I am taking an example. Two example. In first, the element are A, B, C, D, 1, 2, 3, 4. And in second, also the element are A, B, C, D, 1, 2, 3, 4. So A is equal to 1, B is equal to 3, C is equal to 2, D is equal to 4. Here A is equal to 2, B is equal to 2, C is equal to 4, D is equal to 3. So that function, first one is known as one function. Why first one is known as one function? So in that we are getting a unique pre-image of element of B. But that function is not as one function. Second one is not as not one function. That was many one function. Why that was many one function? Because in that we are getting two pre-images of two. FA equal to FB, the image of FA and FB equal, but A does not equal to B. So that function is known as many one function. Okay. So firstly, I'm writing the definition of the many one function. What is many one function? Many one function. A function f from A to B is said to be a many one function if two or more element if two or more element of A have the same images in B, same images in B, and proof of it is fx1 is equal to fx2, but x1 does not equal to x2 for all x1 x2 belongs to A. Taking another example, right? An example: alpha, beta, gamma, delta. Here A, B, C, D, E. Alpha is related to C, beta is related to C, gamma is related to D, delta is related to A. In this, you have seen in the function you are seeing that C has two pre-images, alpha and beta. So f alpha is equal to f beta. They both have the same images equal to C, but alpha does not equal to beta. So that type of function is known as the many one function. Now, the method of finding the many one function, there are some method to find whether function is one or not. First function is your Venn diagram. The topic method to finding method for finding whether the function is one or not, whether the given function is one or many one. Now first one is Venn diagram method. So what this method tell us, you have to unique mapping. Okay, from that you have unique mapping, or you can say unique preimage. Now I'm writing some example. Element are here A, B, C, D, 1, 2, 3, 4. 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 Now A is related to 2, B is related to 1, C is related to 4, D is related to 3. A is related to 4, B is related to 4, C is related to 2, T is related to 1, A is related to 1, A is related to 2, B is related to 3, C related to 4, D related to 3, A related to 2, B related to 4, C related to 1, D related to 3. Okay. Now in the first one, you are saying that two pre-image is 1, one pre-image is B, three pre-image is 2, C pre-image is 4. So that function is 1 function. In the second one, you have seen that 4 have two pre-images. 4 have two pre-images, A and B. So that was not unique. So that was many one function. Unique pre-image is equal to 1. Now in the fourth one, you are seeing that 2 have pre-image A, 1 have pre-image C, 4 have pre-image B, 2 have pre-image D. So it is unique pre-images. So that one is 1 function. Now in the third case, A have image 1 and A have image 2. So that was not a function. Why that was not a function? Because A does not have unique image. A have images 1 and 2. And we have discussed earlier that in the function, you have a unique image. For to be a function, the function from A to B has a condition that firstly, all the element of input are to be mapped, and second condition is that function have unique images. Now next is your second method is fx1 is equal to fx2, then x1 is equal to x2 being your 1 function. Now take the example. First example is f is from r to r, means real number to real number, and fx is equal to x square. And second one is f is from natural number to natural number, and fx is equal to x square. Natural number means the number which are starting from 0, which are starting from 1 and end to infinity. That means all the positive number come here, not any negative come here. So fx is equal to x square. Now fx1 is equal to fx2. So x1 square is equal to x2 square. So x1 is equal to x2 here. So that function is known as 1 function. But here fx1 is equal to fx2 here. So x1 square is equal to x2 square. Now take the example. Real number means all the number negative, positive, decimals all come here. So you have seen that if I put x1 is equal to 2 and x2 is equal to minus 2, so 2 square is equal to 4 and minus 2 square is equal to 4. So x1 square is equal to x2 square. That doesn't mean that x1 is equal to x2, because 2 and minus 2 both have the same images. Okay, so that was not your 1 function, but second one is 1 function, because here input is also from 1 to infinite, so we cannot put here a negative value. Okay, so that was so that's why x1 square is equal to x2 square, we get x1 equal to x2. So that was 1 function, and that was many one function. Okay, now the third method is horizontal line test. So what this test tell us? Wait a minute. Now suppose that was the function. If you stretch any number of horizontal line here, so this horizontal line cut at only one point. So that means that function is one function. But if you take any horizontal line, it cut at 2 points. That means it is not one function. What this function is telling, that was this x1. Okay, that one is x2, and that value is y. So y is equal to fx1 equal to fx2, but x1 does not equal to x2. Suppose this point is 1, this point is minus 1. So 1 does not equal to minus 1. So that function is known as not as many one function. So what the horizontal line tell us, if all the horizontal line of the graph are cut at only one point, so that function is known as one function. And if any horizontal line, at least one horizontal line cut the function at 2 points, so that function is known as many one function. So there exists at least one horizontal line which cut the function more than 1 point. Then we say function is many one. And if all the horizontal line cut the graph of the function at most 1 point, then the function is known as one. Then the function is known as one function. Is known as one function. Okay. Now next method is increasing or decreasing function. Next is increasing or decreasing function. Increasing or decreasing function. If a function is increasing or decreasing, so that function is always one function. So if a function is increasing or decreasing, so that function is known as one function. Okay, so the graph of the increasing function is like that, and the graph of decreasing function is like that. So if you take any number of horizontal line, so it will cut at only one point. So that's why increasing or decreasing function is always one function. Rather, all the function are many one function. Okay. Next is your onto function, or we know it as surjection. Second one is your third one. Sorry, third one is onto function. Onto function is known as surjection. A function f from a to b is said to be one. A function f from set a to b is onto if each element of b if each element of B is mapped with is mapped to at least one element of A of A, or you can say that range of F is equal to codomain of F. The next is your into function. Firstly, I am writing the definition of both the function. Then I will let you know what is into function and what is onto function. Into function. If a function f from set A to set B is into if any element in B is left to be mapped. Okay, so in that case the range is subset of codomain but not equal to the domain. Okay, now next is your bijective function. So what the mean of bijective function? Now firstly I am taking the example of onto and into. Suppose there are two function. First case, the second case, element are here 1 2 3 4 A B C D E and 1 2 3 4 A B C D E. If 4 is mapped with C, 3 is mapped with B, 2 is mapped with A, 1 is mapped with D. So one element is left here. And in the first case, 1 is related to B, 2 is related to B, 3 is related to D, 4 is related to C, and now A and E are not there, B, C, D. So in second case, you are seeing that range is equal to the codomain. That means no element is left in the set B. The set A, set B. But in the second case, the range is A, B, C, D. And codomain is A, B, C, D, E. A, B, C, D, E. So here the range is the subset of codomain. Range is not equal to the codomain. So that function is known as into and that function is known as onto when the range is equal to the codomain. Okay. Now next concept is your bijective function. So what is a bijective function? A function f is said to be bijective if it is both 1 1 and onto. That means suppose that are two element A and B. The element of A are 1 2 3 4. The element of B are A B C D. 4 is related to C, 3 is related to A, 1 is related to D, and 2 is related to B. In that, you are seeing that all element of B are mapped. So that was on to no element is left in the B. That means range equal to codomain, and all element of B have pre-images in A. So that function is known as 1 1 and onto function. What are the two conditions for function to be bijective? Firstly, it should be 1 1. That means the element of B have unique pre-images in A, and no element will be left in B. So that function is known as the bijective function. Now, second is composition of a function. Or you name it as composite function. So what function are known as composite function? Suppose A is f is from that was A, that was B. The element of A are 1, 2, 3, 4, and here A, B, C, D. So a function f is defined from A to B, where 1 is related to A, 2 is related to C, 3 is related to B, 4 is related to D. And second function G is from B to C, where we have element A, B, C, D, and alpha, beta, gamma, delta. A is related to delta, C is related to gamma, B is related to alpha, and B is related to gamma, and D is related to beta. Okay. Now, what is composite function? That means f of G. So f of G means a function is from A to C. Now take three sets. That was A. Second one is B. Third one is C. Now A have the element 1, 2, 3, 4, and B have the element A, B, C, D. C has the element alpha, beta, gamma, delta. Now the mapping is from 1 to A. That was of function f. That was G. So what is the mapping of f? 1 to A, 2 to C, 3 to B, and 4 to D. And what is the mapping of G? A to delta, B to gamma, C to alpha, and D to beta. Now that means in FOG we put 1, so we will get input direct as delta. If we put 2, so we will get f of 2 is C and C is images alpha. F of G of 3, so we will get 3 to B, 3 images B and B images gamma. And f of G of 4, we will get 4 images D and D images beta. So that are the FOG composite function. Okay. So in composite function, the codomain is of domain in FOG is the domain of F, and the range of FOG is the range of G. Okay, that was your composite function. Now the last is your inverse of a function. Inverse of a function. So there are two conditions to be a function to be to find its inverse. it is 1 1 and onto. If a function is 1 1 or onto, that means it is bijective. A function is bijective, so its inverse will be exist. Okay, what is inverse? F is from A to B. That means A is its domain and B is its range. So F inverse is from B to A. So F inverse is from B to A. So in the inverse, the range, sorry, the domain is from A to B, and the domain of F inverse is from B to A. That means the domain of F inverse is equal to the range of F, and the range of F inverse is equal to the domain of F. So that's are your types of function. I have discussed that the type of the function, many one function, on one function, onto function, into function, composite of a function, and inverse of a function. Now all the topics are clear, and we have left now the previous year questions of that chapter. Okay. The first question is, find the domain, find the domain of the real valued function, of the real valued function fx. Fx is equal to 1 upon x square minus 1 and x plus 3. So that's what your function. So what is the solution? So fx is equal to 1 upon x square minus 1 equal to x plus c. That was belongs to, that was a real value function. Real value function means its values are real. That does not contain any imaginary number or any infinite or minus infinite number. So if it is not infinite, so that terms will not equal to 0. So x square minus 1 and x plus 3 not equal to 0 will be the condition. So that's it's proved to its to function as real valued function. So if x square minus 1 and x plus 3 does not equal to 0, so x square minus 1 can be open as x plus 1, x minus 1, and x plus 3 does not equal to 0. Now what it means, that x does not equal to x, if x plus 1 does not equal to 0, so x is equal to minus 1, 1, and minus 3. So the domain of the function is r minus minus 1, 1, minus 3. Means you can put any value except minus 1, 1, and minus 3. So that was its domain. Okay. Now the next question is, question is, if fx is equal to 2x minus 1, comma, gx is equal to x plus 1 by 2 for all x belongs to real number. Find g of x. Find g of of x. Now, what is g of means? G of fx. G of fx means g of fx. Now, in place of x, we can put the value of fx. So, what is x here? 2x minus 1 plus 1 by 2. So, 2x by 2 is equal to x. That was the value of g of fx. Okay. Now, the next question is, if f is equal to 1, 2, 2 minus 3, 3 minus 1, find 2f, and second is f square. Now see the solution. What the function is saying, that if you put f1 you will get 2, if you put f2 you will get minus 3, if you put f3 so you will get minus 1. First is you have to find 2f. So 2 of f of 1 is equal to 2 into 2, that means 4. So 2 of f of 2 is equal to 2 into minus 3, that was minus 6. 2 of f of 3 is equal to 2 into minus 1, that was minus 2. Second, f square. F square means f1 whole square. F1 whole square is 2 square is equal to 4. F2 whole square. F2 whole square means minus 3 whole square. That was 9. F3 whole square. So F3 whole square is minus 1 whole square. That is 1. So that was f square. That was 2f. Okay. Now next question is, if fx, that all are your previous year question, huh? If fx is equal to x plus 1 upon x minus 1, comma x does not equal to plus minus 1, then find f of fx. So the solution, that one is f of x, which is equal to f of fx. So f of fx value is x plus 1 upon x minus 1. That means first we have to put in place of x as x plus 1, x minus 1. So f of x plus 1, x minus 1 plus 1 upon x plus 1, x minus 1 into minus 1. What it means, that you have to put in the place of x that value. So you will get, on taking LCM, so you will get f of x plus 1 plus x minus 1 upon x minus 1 upon x plus 1 minus x plus 1. So that was cancelled. That term will be cancelled. So you will get f of 2x by 2, that means x. So f of x, that means in place of x you have to put that value. So x plus 1 by x minus 1 is the value of f of x. Okay, so that's all for today. In the next class I will discuss some more important question that comes in your previous year. Okay, so if you have doubt in any topic related to this chapter or any chapter, you can send that doubt or that question to sir or madam. They will send me and I